Hello everyone. In this video we're going to talk about factorization of polynomials. Now, before we go into the main topic, let me give you a scenario. So let's say I have this field here. So let me draw a field. So let's say I have this field. All right. This is the field, right? And I have a lawn in this field. So this is the lawn, this is the path of the lawn right here. Then maybe it goes like this, and this one also goes like that, right? And I also have this portion of the lawn that goes like that to this, right? So let me just shade this portion of there. So this is the lawn, the green portion is the lawn. This is the green portion of the lawn. This is the green portion, right? This is the green portion is the lawn. Now let me say this is the width of this field. This is the width. So with the width here, I should maybe 6x. That's the width. And maybe the length should be maybe 10x, right? So let me put it that way. So imagine we are trying to find the area of a lawn so that we can determine how much grass seed to purchase, right? Now we said that the green portion is the lawn, right? So how do we do that? Now the area of the entire region can be found by using the formula of the area of a rectangle, right? So what is the area of a rectangle? Now we know that the area of a rectangle is A, which is area, which is equal to length times the width, right? So W and L, right? Now what is our L and what is our W? So we know that our L here, which is the length, is 10x, and our W here is our 6x. So to find the area of the whole field, we should get 10x dot 6x, and when we do that, we should get 60x squared units squared, right? Now the area of the portion that do not require grass seed need to be subtracted from the area of the entire region, right? Now the two square regions each have an area of, so each of the area of the two portion, so another area, so we have area should be s squared because the portion, those portions are squared, right? And we have each side, let's say, let me go back here, let's say each side is 4. Let me put 4 there, let me put 4 here, and I'll put 4 there, because they are squared, right? So each side is 4. So let me just go back. So to find the area of each portion, that is A is equal to S squared, right? So the area of the squared is 4 squared, which is 16 unit squared, 16, right? Now the other rectangular region has one side of length to be 10x minus 8. That is one side, right? And the other side is 4, which is the other side. You can see that from here, right? You can see that from there. Now with that, the area of that rectangular part is the length times width, right? So with that, we should get the area to be length times width, which is equal to 4 multiplying 10x minus 8, and we should get 40x minus 32 units squared, right? Now, so the region that must be subtracted has an area of the region that must be subtracted has an area of 2 multiplying 16 plus 40x minus 32, which when you do summarize everything, you should get 40x units squared. Now, the area of the region that requires grass seed is found by subtracting the 40 rather from the 60x squared. So that's 60x squared minus 40x unit squared. This area can also be expressed in factored form. The reason I'm giving this scenario is we are gonna factorize this portion or this area that we've gotten here. So this area can be factorized to be let me use black here, to be 20x out. Then when we do it, you get 3x minus 2 units squared, right? Now we can confirm that this is equivalent expression by multiplying. So many polynomial expressions can be written in a simpler forms by factoring. Now in this section, we will look at, or in this video, we are going to look at a variety of methods that we can use to factor polynomial expression. Now the first thing that we are going to talk about is factorization of the greatest common factor, GCF, of a polynomial. This is the first method that we're gonna talk about. Now, when we study fractions, we learn that the greatest common factor, which is the GCF of two numbers, is the largest number that when divided evenly into both numbers. For instance, when we have 4, so let's say we have 4, right? So for instance, 4 is the greatest common factor of 16 and 20 because it is the largest number that divides evenly into both 16 and 20. So the GCF of polynomials works like the same way, right? So let's say we have 4x, right? So the 4x is the greatest common factor of the 16x and 20x squared because it is the largest polynomial that divides evenly into both 16x squared and 20x squared. That's 16x and 20x squared, right? So when doing factorization of a polynomial expression, our first step should be to check for a greatest common factor. That's the first thing that we need to check. Now we look for the greatest common factor of the coefficient and then look for the greatest common factor of the variables, right? So the greatest common factor of a polynomial is the largest polynomial that divides evenly into the polynomial. That's what we are talking about. So how do we do that? So when given a polynomial expression, we factor out the greatest common factor. That's what we do first. Now the first thing that we need to do is to identify. So we identify the GCF, which is the greatest common factor of the coefficient. That's the first thing that we do, right? Now the second thing that we need to do is to identify the GCF of the variables. That's the second thing that we need to do. Now when we are done identifying this, both the coefficients and the variables, their greatest common factor, the next thing that we need to do here is to just combine. We combine to find the GCF of the expression whole, right? That's what we do next, right? So when we are done with this, there are 5 steps that we need to do that. And the next step, which is number 4, is to determine the GCF. So we determine I'm not gonna write everything, just determine the GCF that needs to multiply, multiplied to obtain each term in the expression. Then when we are done, the last thing is to write the factored expression as the product of the GCF and the sum of the terms we need to multiply. I know this is a whole lot. We are going to take an example and know how to do it practically. So let's take an example here. So with our first example, let's factor 6 x3 y3, right, plus 45 x squared y squared plus 21xy. Right, so let's do this practically so that you can understand it very well what I'm talking about here. Now the first thing that we said is to find the GCF of the expression. That's the first thing that we need to do. So the GCF of 6, 45 and 21. So what is the GCF? What is the GCF of 6, 45 and 21, right? So when you look at these three numbers here, what is the GCF of that? We can see that it's gonna be 3. If you can see what I'm saying here, it's gonna be 3. It is 3, right? And the GCF of the variables of which is x3, x squared and x, you can see that the GCF of that is also x. I hope you got it. Now note that the GCF of a set of expression in the form of, let's say, x exponent n will always be the exponent of the lowest degree. Note that. Let me state it again. Let me write it here. Say, always note that the GCF of a set of expressions in the form of x exponent n will always be the lowest degree, right? So finding the GCF of this will not be something difficult for you to do, right, with this statement that I have provided here. Now, and the GCF of, now we have find the GCF of the numbers, which is 6, 45 and 21. And with the variable, we have two variables in the expression. We have the x and the y variables. So with the x variable, we have found it to be x. Now let's find the GCF of the y variable here. So with the y, we have the y exponent 3, the y exponent 2, and y. And with this statement here, we can find this one easy to be y, right? Very easy to do, very, very easy to do. Now our next thing that we need to do is to determine what the GCF needs to be multiplied by to obtain each term of the polynomial, right? So we find that we have 3, which is the first one that we got here, then x, the next one that we got here, and y, the next one. So we have this one. So there's no need of wondering which one should I use, we have them here. Now when we are done with that, we factorize. We can see that with that we should get 2x squared y squared, right, which is equal to 6x cube y cube and 3xy 15xy, right, which is also, it should be equal to 45 x squared y squared. And the last one is 3xy, then the 7, which will also give you the 21xy. So finally, we will write the factored expression as the product of the GCF and the sum of the terms we needed to just multiply, right? So, and by doing that, we should get the 3xy, then 2x squared y squared plus 15xy plus 7, and this is our factored form, right? It's very, very easy to do. So after factoring, we can check our work by just multiplying, then we use the distributive property to just confirm it, right? So you can also multiply to see if we will get the same result as 6x cubed y cubed plus 45 x squared y squared plus 21 xy. Just multiply and see if we will get the same thing, right? So let's talk about another thing. There's another thing that we need to talk about, and this one is called the factorization of trinomial with a leading coefficient of 1. So how do we do that? So although we should always begin by looking for a GCF, which is the greatest common factor, now pulling out the GCF is not only way that polynomial expression can be factored. Just note that. So pulling out the GCF is not the only way that polynomial expression can be factored. What is that another way? Now the polynomial, let's see with another polynomial. So factorization of trinomial with a leading coefficient, of 1, right? This is what we are going to talk about. This is what we are talking about. So now let's take this expression, this polynomial expression. So we have x squared plus 5x plus 6, right? And which has the greatest common factor of 1. You can see it from there. You can see it. The greatest common factor is just 1, but it can be written as the product of the factor, which is x plus 2 and x plus 3. When you factor, this is what you are supposed to get. So trinomial of the form x squared plus bx plus c can be factored by finding two numbers with a product of c. So with the product of c, and sum of b, right? That's how we find we can factor by finding the two numbers with the product of c and the sum of b. Now the trinomial expression which we just stated here, maybe let's take a trinomial expression of x squared plus 10x plus 16, for example, can be factored using the numbers 2 and 8, because the product of these two numbers, right, is 60 and their sum is 10, right? You can see it from there. So we can use 2 and 8, and when you multiply that, you should get 16, which we have here, and when you add it, you should get 10, which we have in the middle there. Very simple to do. Very, very simple to do. Now the trinomial can also be written as the product of the x squared and x plus 8. All right, it's very, very simple. So what is the summary of this? So a trinomial of the form, when we have a trinomial of the form x squared plus bx plus c, we can factor it in the form of x plus p, x plus q, where p and q, pq is equal to c, and p plus q is equal to b, right? So the c here should be equal to p multiplying q, and the b there is equal to p plus q. That's what we are talking about here. Now let's take an example. Now before we take an example, let me ask you this question: can every trinomial be factored as a product of a binomial? Can every trinomial be factored as a product of a binomial? What is your answer? Yes or no? Now, for me, my answer is no. What is the reason? Now, some polynomials cannot be factored. These polynomials are said to be prime. That's my reason, right? You get into that. Now, let's see how we can factorize of a trinomial. Let's look at it. So when we are giving maybe a trinomial in the form of x squared plus bx plus c, now how do we factor it, right? So the first thing we need to do is to list factors of c. So you list factors of c. Second thing you need to do is to find the p and q, which we stated earlier on, and a pair of factors of c with a sum of b, right? And the last thing that you need to do, this is very short to do, the last thing that we need to do is to just write the factored expression as x plus p and x plus q. Very simple to do. Now let's take an example and see how we do it practically. Now with this example, we have let me use x squared plus 2x minus 15, right? Now, so the first thing that we need to do is we have a trinomial with a leading coefficient of 1. This is the first thing that you need to remember. What is the leading coefficient? Now, with the leading coefficient is just 1. You can see from here it's 1, but we don't write it. So, and the b from our main this one, so we have x squared plus bx plus c. So what is our b? Our b is 2, and our c is negative 15. It's not 15, it's negative 15, right? Because when we compare this expression to this, the sign here changes, right? So it's minus, so 15, right? So we need to find two numbers with a product of negative 15 and a sum of 2. So I'm gonna use a table. For me, I'm gonna use a table to make it very easy to do. So with this table, I'm gonna label this part to be factors of negative 15, and this part to be sum of factors, right? Sum of factors. Then I'll draw my table like this. So the first factor is 1 and negative 15. What is the sum of these factors? Is negative 14. The next factor is negative 1 and 15. What is the sum of that? Which is 14. The next factor is 3 and negative 15. And what is the sum of that? 2, right? And the next factor, sorry, this one should be 5. This one should be 5. 5 is 5, right? So 2, right? And the next factor is negative 3 and 5, and the sum is 2. So now we have identified p and q as to be. If you look at it, what is the p and q? Is negative 3 and 5. It's negative 3 and 5. Then we just write in the form that we just talked about, which is so our factor is going to be x minus 3 multiplying x plus 5. Very simple to do. So for me, I just used the table and I did it very quickly. So we can check out by just multiplying. So let's just multiply and see if we are gonna get x squared plus 2x minus 15. Let's multiply and see. So x times x is x squared, x times 5 plus 5x minus 3 times x is minus 3x minus 3 times plus 5, which is negative 15. So negative 15, negative 15. So when you do it, you get x squared then plus 2x minus 15, right? And when we go, we should get the same thing, which is x squared plus 2x minus 15. That's what we have here. So it is correct, right? So this is the end of this video. We'll continue in our next video, so watch out. Thank you for watching.